Good morning, everybody. Thank you very much for showing up in good numbers. This is the last session of this morning, and we realize that we are the people between you and your lunch. So we'll try our best to stick to our time and finish it within our time, although we are starting a few minutes late. So my name is Kamran Naqvi. I'm Principal Architect at Broadcom, based in the UK. And with me, I have my colleague, Jens Jetzork. He's a DevOps Engineer from Deutsche Telekom, based in Germany. So this is how the session will flow. Jens will start by introducing the SCHIFF project to you. He will talk about the various network topologies they use in their deployment, and then he will move on to talk about various host connectivity types they have in Deutsche Telekom. And then Jens will introduce you to a homegrown tool called Network Operator. I will then take over and I will talk about the unique approach that Deutsche Telekom have adopted for their network monitoring. It's container-based. I'm sure it's going to be interesting for you. And then we will finish off by talking about third-party container management or TPCM infrastructure that Broadcom developed. So that's the agenda. Now, without further ado, I will hand over to Jens.
Yeah, thank you for the introduction. With you heard already, I'm working for the SCHIFF, which is called in English the SCHIFF, just for the not German native speakers here. We got the task to build an on-prem cloud within Deutsche Telekom to onboard our Kubernetes cluster as a service workloads. We did it just internally and by using GitOps. And we did that to enable network technology workloads like the 5G core, 5G campus, or even PCF. And we tried to build that by almost using open source components. Currently, we have more than 150 clusters up and running, which are providing more than 40 apps. And we have more than 170 OCP accepted SONiC switches, which are provided by the vendor EdgeCore, which are running the open rating system from Broadcom. And we are doing that in 6 data centers currently. When we go over to the next slide, we can see the traditional layout, which we are still using for some clusters, which are not migrated yet to the new design because of some capacity problems, because compute resources are hard to get. And on the left side, you can see 2 clouds, which could be, for example, a backbone, like in our case of our company, with multiple VRFs in it, but it could also be whatever connection you will imagine. In the middle, you can just see a firewall, which could represent a 3-tier design like we use. And on the right side, it's a VLAN, which could be represent more than one VLAN. We have a bunch of that, like 1, 3, 5, whatever. And at the end, we have the connected worker nodes, which is consuming that stuff by using a trunk port. And the worker node itself will run Calico in full mesh mode. And it's do the communication between the machines by using IP and IP or VXLAN. We thought about that is not a good solution for our dynamic workloads because we want also have dynamically the stuff from the worker nodes itself assigned to the backbone. For that reason, we exchange in the middle the firewall. We replace it by a cloth fabric. And we have a spine leaf fabric in place there. And you can see on the right side that we exchange the different VLANs by using VXLANs right now. When we go from the bottom up, you will see that the Kubernetes cluster will also have a VXLAN, which is only used for the cluster cross communication between the different worker nodes. And then we have a bunch of VXLAN, which is then maybe pointing to network 2, for example, if we go from the bottom up, or we have specific VNIs, which then pointing to the network 1. And all of them using for that slide, EVPN type 5. To advertise a different layer 3 route there. The worker nodes will announce their pod IPs, which are used still into the VXLAN, and announce their IP itself. So it's not done by the fabric. The server will do it because we stretched out the fabric down to the server and running their free range routing as well, which will be shown a bit later. If we have a look right now from to the network topology in general, you can see in the middle there is a big green arrow, which is pointing out that the VRF and the VNI is by using the VNI is stretched down to the worker node. You can see at least 4 green lines, which are representing the connection from the worker nodes to the leaf switches, which are by a cloud native way 4 times 25 gigabytes. And you can see an additional purple arrow on the left side, which is pointing from border leaf to leaf T-base, because there we have the access ports of the light load management interfaces to connect these interfaces as well. And we place then there the static anycast gateway. And for the reason when the packet hits the leaf T-base and the switch needs to be aware of, to reach, for example, management system, the leaf T-base needs to know where the routing needs to point to. Then we have a special case instead of the cloud native stuff from the last slide, that we have some customer which are using SRIOV. In that case, we have a EVPN type 5 connection between border leaf and leaf. And we will cut out 2 out of the 4 times 25 gigabyte interfaces, which will be configured at trunk port, that the cluster can consume it and the pod can consume it as well. And the rest of the fabric stays like it is. Beneath the traffic from north to south, we have also east-west traffic. You can see for leaf and leaf T-base that we have BGP EVPN type 2 sessions. One part for SRIOV, the other part for the management purpose, for the lights of management interfaces. That's there to exchange the different MAC addresses and also the ARP entries. And as I've mentioned, also the server will have EVPN type 5 in between to exchange the pod communication and so on. We have one additional use case which is not shown here. We are also able to provide MAC VLAN and IP VLAN connection, which is done from the perspective from this presentation, just normal by cloud native, by using EVPN type 5 between worker and border leaf. But the server itself will take care around to provide the VLAN and the static anycast gate for that use case. If I go over, we come to the network operator, which is provided by SCHIFF, which could also be found by SCHIFF network operator via SCHIFF network operator by Google. And we have 3 different inputs. The first one is the site configuration, which contains all the information, for example, which VRF will be available, which VNI is assigned to this VRF. And then we have some custom resources as well for the layer 2 configuration, like I mentioned, for VLAN or IP VLAN, where we then add the VLAN configuration, the VNI, and the static anycast gateway. And at the end, we will have as well the VRF custom resource, where we then provide the EVPN type 5 configuration and the VRF, which is stretched down to the server. The network operator in the middle takes place to translate all this stuff into the free range route configuration and into the Linux netlink commands. There is a short summation, what I've discussed right now. The custom resource will be translated by using the network operator. It will create the VRF, layer 3 VNI, layer 2 VNI, and the VXLAN interfaces. And in case we are using MAC VLAN or IP VLAN, we will also provide then the static anycast gateway by using that operator. And in case we are using the layer 3 VNI, we will have, if it's needed, the route leaking there, the route maps there, and so on. On the right side, you can also see an example file for our custom resource. In that case, the VRF route configuration. And for that reason, we just configured, for example, the VRF BBM2M, and we defined an import and export list to filter the traffic. Now I'm through my slide deck, and I will hand over back to Kamran, who is to provide some details for monitoring SONiC. Thank you.
Thank you very much, Jens. All right, network monitoring. Now, there are a number of monitoring solutions available for SONiC. The management framework that Broadcom developed for SONiC and upstreamed to the community, it's a very flexible management framework. You have a lot of API access into SONiC. You have a lot of OC YANG models available into SONiC. So we pretty much say that if you want to monitor SONiC, bring your own monitoring solution and it will work with SONiC. But because the Deutsche Telekom team, they've been building this cloud native environment, it was only natural that they wanted to, there was strong inclination from the Deutsche Telekom team to use a cloud native type monitoring solution. And when we look at the cloud native environment, we see that the Prometheus is probably the most popular monitoring solution for cloud native environment, including Kubernetes. So once again, it was only natural that Deutsche Telekom team aspired to use Prometheus-based solution for monitoring their SONiC solution as well. But there was a challenge. This solution was not optimized to monitor network environments. It was not monitoring the right network metrics. So what do? So Deutsche Telekom team and our partner STORDIS, they gathered together and they started to fix this problem. The aim was to make this Prometheus monitoring solution fit for purpose for SONiC. And the result of their endeavor is what we call Project Monsoon. So what you see on the right-hand side here, this is a graphical representation of Project Monsoon. As you can see, it comprises 3 layers. At the bottom layer, we have data collection agents. And you can see there are 2 data collection agents being used in Project Monsoon, Node Exporter and SONiC Exporter. Remember, both of these data collection agents are running on every SONiC switch as container, as a third-party containers. Node Exporter is the default exporter for Prometheus. It's an open source solution. It talks to Linux kernel, and it can provide you hardware and OS related metrics. Metrics like CPU utilization, metrics like memory utilization, disk utilization, and so on. But on the other hand, SONiC Exporter is something which is specifically developed under Project Monsoon to monitor SONiC. SONiC Exporter, as you can see, talks directly to Redis database. And it can provide you some unique network-related metrics. So it provides you metrics like BGP pairing information. It provides you metrics like VXLAN EVPN information, metrics like MC lag information, NTP information, and so on. If we move up the stack, the second layer in Project Monsoon is Prometheus server itself, which is the data collection tool. So what this Prometheus server is doing, it is going out, talking to both of these agents and pulling all these metrics and then saving them as a time series data. The top layer, I'm sure everybody know about it. This is Grafana, which is a visualization tool. So what Grafana is doing, it is reading this time series data, and Grafana is making all these beautiful graphical interface and dashboard for you to show you how your network is behaving. So this is how network monitoring is happening in Deutsche Telekom. But if you want to know more about Project Monsoon, I would like you to meet my friend Kamal Bhatt. Kamal, if you don't mind, can you please stand for a minute? So Kamal is the software architect for Project Monsoon. He did a wonderful session yesterday, a deep dive into Monsoon and a demo in the SONiC workshop. It should be available on YouTube in a day, in a week, hopefully. And he's also doing a live demo of Project Monsoon on the STORDIS booth outside. Still doing that, right? So if you're interested, I would suggest, talk to Kamal and have a look at it. Thank you, Kamal. Wonderful job, yeah? All right, which takes me to the last topic of the day. All right, third-party container management. In the last slide, I showed you how Deutsche Telekom are using 2 containers on every switch to monitor their solution. Last year at OCP Global Summit in San Jose, we presented with Lines Corporation, our customer from Japan. And they are using 4 containers per switch. And they have their use cases for that. So it's good, it's great actually, that customers are leveraging this SONiC flexible architecture and they are running their apps and their containers on it. But at the same time, it is imperative that there are boundaries and limits on these containers so they do not impact the core services running on SONiC. Would you agree with me? Yeah. And that is what third-party container management is doing. So we at Broadcom developed this TPCM, which gives you a safe environment where you can run your TPCs, your third-party containers, but there are limits on the resource utilization, so your core services will not be impacted. But that's not the only thing which TPC is doing. TPCM provides you a flexible environment for installing, upgrading, and deleting your containers. I already talked about the resource limits. By default, TPCM, what is the limit on TPCM by default? 20% of the resources. So all the containers that are running on SONiC, third-party containers, there is an upper limit of 20% utilization. 20% CPU, 20% memory, and 20% disk. They won't go above it. Is it flexible? Yes. You can change, you can tune your memory and disk utilization, but CPU utilization is fixed at 20%. That is a ceiling. Now, if you install a SONiC, if you install a third-party container on SONiC, use a Docker command. Can you do that? Yes, you can. But when you do that, there is a limit that the network access will only be available in the default VRF. But there was a requirement from one of our customers, actually from Line. They wanted their container to access management VRF. That is something that we have enhanced and provided in TPCM as well. Now, we have another customer, and their requirement was that they wanted their container to run when the SONiC system is ready, after all the services are ready. So we also provide you this customization. You can choose, you can customize when you want to run your container. If you want to run your container after certain number of services on SONiC are ready, and before other services start, you can still do that. There is a lot of customization available with TPCM. And last but not least, think about it. Think about the OS upgrade. This is my last point. When you upgrade SONiC from, say, 3.x to 4.x, and say you installed your containers using Docker command, will your containers be there after the upgrade? Answer is no. Your containers are gone, all your configuration is gone, all the data is gone. But if you are using TPCM, when you upgrade SONiC from one version to another version, all your configuration, all your data of the third-party container is preserved. TPCM will migrate all your containers in a seamless manner. So hopefully you can see that TPCM is a useful tool. And we at Broadcom would encourage everyone to please go and look at the TPCM HLD, and we would welcome any feedback from you. All right, call to action. I think this is yours.
If you like to know about something more about the SCHIFF or in general for the network operator, you can follow up this GitHub link, which is pointing to the SCHIFF network operator in general. And if you want to know more about the project SCHIFF, or also known T-CaaS cluster as a service, you can follow up the YouTube video. I guess there will be added more because we are also in parallel on the KubeCon.
Perfect. These are the links for this is the GitHub link for the project Monsoon. It is open source. You can download, you can use it in your own environment. Its a demo is actually already there. The second link here, if you click on that, it will take you to the live demo for project Monsoon. And the last link here, this is my YouTube channel where I make how-to video on SONiC. So if you're interested to configure SONiC, you can look at that. Thank you very much for your time. Appreciate it.
Thank you, everyone. We have a bit of time for questions. Any questions? I know we're right before lunch. Any questions for the folks up here? Yeah, one. I'll run back here with the mic. That's all right.
Yeah. Sorry, I didn't mention difficult questions are not allowed. Say.
No, it's more like a question towards the future of this TPCM, for example. I think last time I looked at SONiC, there have been like a couple of people interested in looking at Kubernetes or something smaller as the management engine, basically, for the containers running on that. There's like a working group. There's not too many people, or it's dying off from time to time because nobody actually ports it, I guess. So how do you see these... I think the stuff that you're doing for the TPCM aligning with what other people are trying to do with the Kubernetes stuff, because it would basically give you an already standardized way of managing containers on the platform, limiting the resources, all this stuff. How do you see those two things aligning?
No, I think that's a good approach. That's an approach which the Deutsche Telekom team also aspired. They also wrote something on GitHub. You can see that. Managing SONiC through Kubernetes, I think it's probably a vision many people have. Can this be materialized? Difficult for me to say. Have you heard about Hedgehog? So SONiC Hedgehog, that's also an interesting project. Let's keep an eye on that. They are also adopting similar approach for orchestrating SONiC-based switches using Kubernetes. So treat SONiC switches as Kubernetes nodes. But yeah, good question. And that is something which many people are looking at. All right.
Any other questions? If not, I believe lunch is outside. Thanks so much.
Thank you very much. Cheers.